Hi, everyone. Today's lesson is on coordinate geometry and proofs. So let's get started with a warm-up. We're trying to find the intersection between a line and a circle. So this value right here, this is my line. This value right here, or this equation right here is my circle. So equation. So I'm going to graph the line first. To graph this line, I'm going to put this in slope-intercept form, which means I'm going to solve for y. So we have negative y, moving the x to the other side, is equal to negative x minus 5. Multiply everything by negative 1. We're going to get y is equal to positive x plus 5. So here's the equation of my line right here. I'm going to graph that. So up 5, 1, 2, 3, 4, 5. So here's my graph. Starts here for my equation of my line. Slope is up 1 over 1, okay? And I could also go down 1 over 1. And because of the slope being 1 here, it's a positive slope, so it's going to go up this way. This right here is a circle. This one looks like it has a radius or a center of 0, 0. So my center is at 0, 0. And my radius, well, r squared is equal to 37, which means r is equal to the square root of 37. And the square root of 37 without a calculator is approximately 6.1-ish. So which means I'm going to go over 6 and a little bit more than 6, up a little bit more than 6, that way and this way, so that my graph will look something like this. Now, this is in no way accurate because I didn't count all the way over, but we're trying to find the intersection, which means I'm trying to find both of those 2 points. So in doing that, what I'm going to do is, because I've already solved for y here, this is a system of 2 equations. I'm going to plug one of my equations into the other. So in doing that, since I've already solved for y, I'm going to plug y into this second equation. So I have x squared plus y squared. So this is y. Let me put this like this so you can see what I'm doing. X plus 5 quantity squared equals 37. I'm going to simplify this. So I have x squared plus this I'm going to actually FOIL. So x plus 5 times x plus 5 equals 37. So I have x squared plus FOIL. I'm going to get x squared plus 5x, which is plus 10x, plus 5 times 5, which is 25. I'm going to subtract 37 is equal to 0. The reason why I moved this 37 to the other side is because I noticed that my graph is quadratic. And if my graph is quadratic, you do want to set it equal to 0 so you can either factor or use your quadratic formula to solve. So right now I have 2x squared. I have plus 10x. And 25 minus 37, what is that? That's 12. So subtract 12 is equal to 0. I do notice that all 3 of my terms are divisible by 2. So what I want to do right now to make life a little bit more simple is to divide everything by 2. And in doing that, I get x squared plus 5x minus 6 is equal to 0. And I'm going to factor. I could use the quadratic formula. That would be completely fine. But I'm going to just factor because I noticed that I can say either negative 6 times 1 or positive 6 times 1, which I believe that's going to be positive 6 times negative 1, because 6x and negative x add up to be positive 5x. Split this up. I have x minus 1 equals 0, so x equals 1. I have x plus 6 equals 0, so x equals negative 6. So right now, I have 2 answers for x. I have this point over here, which looks like it's over 1 and up some number, so 1 something. And this point right here, which means it looks like I'm over 6 and then down something. Not sure what, but I'm still looking for those intersection points. So now what I'm going to do is I'm going to take both of these 2 points separately and plug them back into one of my original equations. Now, just this one just looks a lot easier, so I am going to plug it into that. So In doing that, we're going to start off with the equation y equals x plus 5. We're going to plug in both of these x's, this one and this one. So first I'm going to plug in when x is equal to 1. I get y equals 1 plus 5, and that's going to be 6. So when I plugged in 1, see up here at the top, that's 1. I got 6, so there's my first answer. My first point of intersection is 1, 6. Then when I plug in -6, I'm plugging in the same equation, y equals x plus 5. Now x is now -6. So -6 add 5, so I get y is equal to -1. So -6, -1. So my 2 points of intersection are -6, -1, and 1, 6. So moving on, so that was a nice warm up. Moving on, we're going to get into coordinate geometry proofs. So in doing that, the first thing you're going to be using are a lot of shapes. And best way to put these shapes on your axis is not like that. Best way to put the shapes on your axis is to put them just perpendicular right there on the edge, so that everything is going to make life a little bit easier when you're plotting your points, etc. You know, this point right here in the middle, this is always going to be 0, 0. Moving over B, this length is B. So this point right here would be B, comma, up, 0. If my height is A and I moved over B, this point right here would be B, comma, A. And this point right here, again, I didn't move over any, so it's just going to be 0, comma, up, A. So those would be the points. And since I have it right on my axis right here, I could find the lengths of my sides pretty easy. I could find my diagonal lengths. I could do a lot of things, find the slopes, etc. So pause the video for a minute and try to figure out what these points are. So you're trying to find A. This is A. So you're trying to figure out what the point A is. You're trying to find out what the point E is. Well, we know it's -m something. F is something N. So try to figure out all these points and then turn the video back on. So in doing that, for the first one says OAB is an isosceles triangle. This being an isosceles triangle, it means these two sides are congruent. It also means these two angles are congruent. Now, in addition to that, it means that because it's isosceles, if I were to draw my altitude straight down like this, okay, it would actually divide my base into 2 equal parts. Well, see how this is the point 2F? That means I went over 2F. So this distance from here to here is 2F. This being an isosceles triangle with these sides equal, my base is the same. That would be 2F, that would be 2F. So this point right here would be, this point right here would be 2F plus 2F, and 2F plus 2F would be 4F. And then because I'm not going up any, I'm just stuck here at 0. So it'd be 4F, comma, 0. Now, this one right here, this is 0, 0, right here. This one would be over P, but not up any. So that would be P0. So G is P0. Now, a couple of things with this. Number one, for E, how far did we go up? Well, this one we went up N. Because this is parallel to this right here, those values that are going to be exactly the same. So this would be -m N. Now, I think the most tricky part of this is just trying to figure out what this value is here for the x coordinate on the F. In that case, what you're looking at is this distance right here. You know that that's a length of M. That distance is the same distance if I were to draw another perpendicular line, these perpendicular, which is my axis. This would be the same length as this, meaning this is M. Well, the distance from here to here is P. But if I take away a little bit of this, M actually, this value is going to be P minus M. So RACH is an isosceles trapezoid. And this being an isosceles trapezoid, again, these are equal. And then this does divide this down the line, right in the middle. And these are symmetric. So for this one right here, this would be 2c, comma, 0. And this value over here on the left, because this is 2c, this would be negative 2c, comma, 0. Now this one is over 2a. Notice that this is aligned with this right here. It doesn't go all the way over. So this from here to here is 2a, which means from here to here going in the negative direction will be negative 2a. And then how far did I go up? Well, I went up 2b. This one, your point I, which is right here, is 0, 0. This point right here is over j, but up none, so j0. This is going to be over j and up the same value as this. So this would be over j and up w. This would be over 0 and up w. So getting started with our coordinate proofs, there's a lot of ways to plan the proof, and one of the best ways to plan the proof, well, there's key steps to planning the proof. So let's go over a few key steps. The first key step is to draw the actual polygon in a convenient location. We just talked about that. Try to put your shape, whatever it is, right on the axis. Right here, just lay it on there. This is the best place to put it. Make sure you label your coordinates with variables, not with numbers. Don't start counting over. You're not doing that. You're making it for any any rectangle, any square, any parallelogram. Okay, so you're using variables. Number two, use algebra on the coordinates of your finger. So basically, you're going to be using algebra to prove whatever your proof says to do. And lastly, you're going to be writing a 1 to 2 sentence conclusion. You know, you might be using this therefore, the conclusion explaining why. Okay, so you're going to do that for every one of the problems. So plan it, execute it, and then conclude what it is that you're trying to say. So some people may have a little trouble trying to figure out, well, what formula do you use? So there is sort of a guideline. When you're trying to find segments are congruent, you want to use the distance formula. And the distance formula is going to be the square root of, and this is the distance formula, subtract your x's, square them, plus subtract your y's, and square them. Now, subtracting my x's, that x sub 2, x sub 1, that just means I'm choosing to subtract my second x minus my first x, my second y minus my first y. Segments bisect each other. For segments that bisect each other, something maybe, let's say, a parallelogram, and I'm trying to show that my segments bisect each other, well, if I did that, wouldn't they have the same midpoint? So for this one, to show that segments are bisecting each other, I would use the midpoint formula. And the midpoint formula, and I'm not talking about the midpoint theorem, it's the midpoint formula. And that just says that to find the midpoint, x midpoint, y midpoint, you're going to find the average of your x's and y's. So you're meaning finding the average, you're going to go x sub 2 plus x sub 1 and divide by that by 2. That's an average. And you're going to go y sub 2 plus y sub 1 and divide by 2. So that's your finding your average. To show that lines are parallel, well, parallel lines have the same slope. So for this one, I'm going to use my slope formula. And my slope formula, some people use M, some people use A, some people say change in Y over change in X, which is just delta Y over delta X. But all of them use this same thing where you're subtracting your Y's and you're dividing by subtracting your X's. So subtract your X's. And lastly, to show that lines are perpendicular, what you would show is that the product of the two slopes are equal to -1. So the product of the two slopes is equal to -1. So what formula would I use? Of course, I would use the slope formula. Okay, but remember that, let's say my slope is 5. The slope of the line that's perpendicular to that would be -1/5. So if I were to multiply those together, so 5 times -1/5, I'm going to get -1, and that's what I'm talking about. So we're going to start off with this proof right here. This proof says the diagonals of a rectangle are congruent. Now this happens to be page 12 in your packet. So if you don't have that out in front of you, get that out now. So the point, we're going to first label the points. And so we have this point being 0, 0, because it's right here. This point up here is going to be over 0, but up D. This point is over C from that, and I didn't go up any, so that's 0. So my job is to prove that the diagonals of my rectangle are congruent. Well, I'm going to prove that the lengths then are congruent. So I'm going to say the distance between here and here is equal to the distance between here and here. So my diagonals are going to go, let's see here, find the distance. I'm going to subtract my x's. So I'm going to say C minus 0, square that, plus C minus 0, D minus 0, quantity D minus 0 squared is going to equal the square root of C minus 0 is C squared is C squared, plus D minus 0 is D squared is D squared. And that's it. So what did I just find? I found ON. So this value is ON, okay? Don't do anything with this. You can't do anything with this. Don't try to take the C and D out. You can't. This is what you get. That's it. Leave it. And hopefully the other diagonal will have the same length. And therefore, we're proving that the diagonals are congruent. So we just found ON. Now let's find MP. So we're going to use the distance formula again. Okay. And I'm going to subtract my x's. So you can go 0 minus C, or you can go C minus 0. Either way is fine. I'm going to go right minus left. So x minus x. So C minus 0. So C minus 0 quantity squared plus D minus 0. D minus 0 quantity squared. So square rooting that, let's see. C minus 0 is C. C squared is still C squared. This is going to be D squared. And my two lengths, the measure of ON is equal to the measure of MP. These are equal. They have equal lengths. If ON is equal to MP, comma, then the rectangles diagonals are congruent. So that's my little summary to conclude what I just said. Okay, moving on. We are going to prove using coordinate geometry that the diagonals of a square are perpendicular. Now, a couple of things. Diagonals being of a square are perpendicular. That means I'm going to use that product where I'm going to multiply my slopes, the first slope plus the times the second slope is equal to -1. So I'm going to prove that. Secondly, this is in page 13 of your packet. So if you could get that out, that would be great. So the first thing we're going to do is we're going to find the slopes of the diagonals to prove that they're perpendicular. So first I'm going to make my square here. And if you have, I'm going to label this A. Here's my square like this. A. This I'm going to call B. I'm going to call that C, and I'm going to call that D. You can call it whatever you want. That's up to you. But I'm going to draw in my diagonals. And I know this is I'm trying to prove that they're perpendicular. So here's the thing. I need to label my points. So this point here obviously is 0, 0. Now, this is where it gets a little bit tricky. What are my other points? So if you could take a minute, maybe pause the video. So try to fill these in yourself. All right, let's see what you did. We have 0, 0. Now I'm going to call this length A. All right, so that means over A up 0. So this is A, 0. And so what I would put for this right here, remember, this is a square, and a square has 4 congruent sides. So if this length is A, so is this length, and so is this length, and so is this length. So if I go over A, that means that's up A. So this point right here is AA. And then this value going over 0 up A, so this will be 0, comma A. So now we have our 4 corners. And what we want to do is our plan of action is to use the slope formula, okay, to determine if the diagonals are perpendicular. So to find out if the diagonals are perpendicular. So that's what we're going to try to do. So let's find the slopes. So the slope of, let's see here, AC. Let's find AC. The slope of AC. So remember, to find the slopes, we're going to subtract our y's over subtract our x's. So we're going to go A minus 0. So that's because that's a y. A minus 0. So A minus 0 over A, my x coordinate, over, or excuse me, A minus 0. So A minus 0. So A over A, what I have is A over A, which is 1. Okay. Now I'm going to find the slope of BD. So the slope of BD is going to be, let's see, I'm going to subtract my y's over subtract my x's. So subtracting my y's, I'm going to actually start with this one first. So I'm going to go 0 minus A, so 0 minus A, and A minus 0, A minus 0. So it looks like I get 0 minus A is negative A, and A minus 0 is A, and negative A divided by A is negative 1. So if these are perpendicular, then their product, which is 1 times negative 1, should equal negative 1. Does 1 times negative 1 equal negative 1? Yes. So therefore, you can say that AC is perpendicular to BD. Okay. Okay, next one. Prove that the quadrilateral EOGF is a parallelogram. I'm not sure if this is in your packet, or I don't remember seeing it, but this is a good practice. Prove that the quadrilateral is a parallelogram. Okay, so for this problem, this is kind of a really cool problem because you actually have like 4 different ways that you can do this. Number 1, you can prove that both pairs of opposite sides are congruent. So I can use the distance formula. I can also prove that one pair of opposite sides are parallel and congruent. Okay. I could also prove that, let's see here, both pairs of opposite sides are parallel. Okay. And, oops. See here. Another thing I can do is I can prove that my diagonals bisect each other. And I could do that by finding the midpoint. So you actually have so many options. You have so many choices for this. So you just have to decide, what do you want to do? So I'm going to do a little bit of both. I'm going to do a little variety. So I'm going to prove that this is a quadrilateral, or excuse me, this quadrilateral is a parallelogram by proving that, let's see here, what do I want to do? I'm going to just say this is parallel to this, and this is parallel to this. Slopes are going to be, okay, let's do that. So I'm going to prove that, my plan is to prove that both pairs of opposite sides are, actually, I'm going to take that back. I'm going to prove that one side is parallel and congruent. That way I can use the distance formula and the slope formula. So our plan is to prove that one pair of opposite sides are parallel and congruent. That way I can show you both ways. Okay, so first let's show that the sides are parallel. One opposite sides are parallel. So in doing that, we're going to use the slope formula. So I'm going to find the slope of EF, and I'm going to find the slope of OG. Okay, so let's find the slopes for that. So we're going to use the slope formula. So in doing the slope formula, I'm going to subtract my y's over subtract my x's. So subtracting my y's. So this is EF. Okay, here I am. N minus N. Okay. And P minus M minus negative M. So N minus N is 0. And negative M, so these two make plus. Negative M plus M cancel. So I just have 0 over P. 0 divided by anything is 0. Okay. So to find the slope of OG, here's OG, I'm going to subtract my y's, so 0 minus 0, 0 minus 0, and P minus 0. And so 0 minus 0 is 0, and P minus 0 is P, but 0 divided by anything is still 0. So my slopes are actually parallel. So I can actually say EF is parallel to OG. So far, I have one pair of parallel sides, one pair of opposite sides that are parallel. Okay, so now I want to prove that one pair of opposite sides are congruent. So I want to find the length of EF, and I want to find the length of OG. Okay, so the length, meaning I'm going to use my distance formula. And so in doing that, I'm going to get, let's see here what I'm doing, EF. So subtract my x's. So I'm going to go P minus M, parenthesis, P minus M minus negative M, quantity squared, plus, subtract my y's, N minus N, quantity squared. So these make plus. I have negative M plus M, cancels out. P squared is P squared. So I have P squared. And then N minus N is 0. 0 squared is 0. So right now what I have is the square root of P squared. Well, the square root of P squared is P. And so right now I have the length of EF is P. So let's try to find the length now of OG. Okay, so let's move this down a little bit. Okay, so the length of OG, all right, is, where's OG? Here it is right here. So again, we're going to subtract our x's. So I've got P minus 0, so P minus 0, quantity squared, plus, now subtract my y's. 0 minus 0, well, that's 0. 0 squared is 0. So what I have is, it looks like P minus 0 is P squared is P squared, and 0 squared is still 0. So the square root of P squared is P. So what I have now is both of my slopes are equal, and both of my lengths are congruent. So I could say that because EF is parallel to OG and EF, segment EF, is congruent to segment OG, then my quadrilateral is a parallelogram. So therefore, EOGF is a parallelogram. Okay, cool. Awesome. All right, number 4. This one is in page 15 in your packet. Okay, so you're saying prove that using coordinate geometry. So this could be a little bit tricky. Let's see here. It says the midpoint of the hypotenuse of a right triangle. So the midpoint of the hypotenuse of a right triangle. So that must be right. That must be my midpoint. is equidistant from the 3 vertices. So I'm trying to prove that this length is congruent to this length is congruent to this length. Oh boy. So what we're going to do is, let's fill this in. Let's fill in our points first. This is going to be helpful. 0, 0 is this point right here. 2b, comma, 0 is this point there. So now if I went over 2b, this point here being, because these are isosceles, this value coming straight down is going to cut this into half. So if this is 1b, 2b, this is 1b. So this is b. And remember, going up, if this is 2a, because here's another isosceles triangle this way. You see this triangle right here? Isosceles, cut this in half. That means that length is the same as that length there. So this length, this distance right here is going to be a. And let's see here, over b up a. This is over 0 up 2a. Okay, cool. Our plan, what's our plan? We're trying to find out that the hypotenuse is congruent to this line. This length is congruent to this length, is congruent to this length. So my plan of action is to use 3 distance formulas. That's what I want to do. So I'm going to find this distance here, which is mn. So I'm going to find mn. I'm going to find OM, and I'm going to find this length. What is this? PM. All right, so that's my job, to find all 3 of these. So to find, to find, let's see, MN, where's MN? Here it is, right here. So to find MN, I'm going to use the distance formula, and this is 2b, comma 0. So I'm subtract my x's. So I'm going to get 2b minus 1b, quantity squared, plus 2b minus 1b, 0 minus a, so 0 minus a, quantity squared, is equal to, let's see, 2b minus 1b is b. B squared is b squared, okay? 0 minus a is negative a. Negative a times negative a is a squared. So that goes b squared plus a squared. So I'm going to hold that thought for a minute, and now I'm going to find OM. Where's OM? Here's OM. There's OM. So again, I'm going to subtract my x's, and I'm going to go b, this x here, b minus 0, so parenthesis, b minus 0, quantity squared, plus a minus 0, so a minus 0, quantity squared. And so I'm going to get b minus 0 is b squared is b squared. A minus 0 is a squared is a squared. Do not even think about taking these out of here. They don't, that's it. This is simplified. You cannot take any values out of there. So far, so good. So far, we have 2 congruent sides. So now we're going to do the third side, which is PM. So here's P and here's M. So we're going to find this length and see if it's the same length. So again, I'm going to subtract my x's. So I'm going to go b minus 0. So b minus 0, quantity squared, plus a minus, parenthesis, a minus 2a is going to be b minus 0, quantity squared, is b squared, plus a minus 2a is negative a. Negative a squared is positive a squared. By the way, it's okay if a squared and b squared were in different orders, but that's how you do this. So therefore, we know, we just proved that mn is congruent to OM, is congruent to PM. And so because all segments are congruent, it is a right triangle with equal points to each of the vertices on the hypotenuse. All right, cool. So that concludes this lesson on coordinate geometry and proofs. I will see you day 2. Thanks for watching. I hope this helped.